Properties of equilibrium constant. After understanding what exactly equilibrium constant is, how it is expressed, its types Kp and Kc, we must know now the properties of equilibrium constant. It is applicable for both for Kp and Kc. The first property of the constant is, must know that it only depends on temperature and varies with temperature, and no other factor can change the value of equilibrium constant for a reaction. That's the basic property. Even if you change the concentrations or the temp or the pressure of the reactants or the products involved, nothing is going to happen, because this constant will remain as a constant for a reaction until and unless the temperature in which the reaction is allowed to take place is changed, because K equilibrium only depends on the temperature. Now, the second most important is that if suppose we have an example like A moles of A is converting into B moles of B, equilibrium constant for this is K, and the reaction, now the new reaction is B moles of B converts into A moles of A. It means what? Now we have reversed the reaction which is involving equilibrium K dash. You must know this K dash is the inverse of the previous equilibrium constant. It means what? Once the reaction is reversed, the new equilibrium constant is the inverse of the previous one. If it is 1 and if it is K dash, this K dash is 1 upon K1. It is clear? Third property. If the reactants and the products of the reaction are multiplied by X, the new equilibrium constant K dash is expressed as, like let's take A moles of A combines with B moles of B, giving you C moles of C and D moles of D. The equilibrium expression was, let it be having an equilibrium K equilibrium. Now once we multiply this whole by X, it will be XBB, XCC, XDD. This is K equilibrium, the new one, K dash. Then this K dash equilibrium constant is the X times power of the previous equilibrium constant. Now, how we can use this information of X? Suppose if this X is square, that means we are actually doubling the concentrations of all the reactants in the product. Your new equilibrium constant will be the square of your previous equilibrium constant. Similarly, if your X is cube 3, it means we are multiplying the concentration of the reactants, the products by 3, we are actually making them to become 3 times, then the new equilibrium constant will be the cube of the previous equilibrium constant. Also, if your X is suppose 1 by 2, that means you are exactly doing the half of the concentration of the initial concentration of the reactants and the product, then your new equilibrium constant K dash is the 1 by 2 of your new previous equilibrium constant. It means what? It can be expressed as your square root of your previous equilibrium constant. Also, if your x is 1 by 3, then your new equilibrium constant is the cube root of your previous equilibrium constant. So this is a very important property, that if you are multiplying it by certain times, or we are dividing it to a half or of a 1 by third, then what will be the new equilibrium constant values? It is exactly to the power x. If it is double, it is square. If it is triple, it is thrice. If it is half, it is square root. If it is 1 by 3, it is cube root. Another property is that if the reaction is divided into two or more steps, each involving its own equilibrium constant, then overall equilibrium constant will be the product of all the equilibrium constants of these steps. Example, if A moles of A combines with B moles of B, the equilibrium constant is K equilibrium. Now this same reaction is allowed to take place in steps, that A moles of A combines to gives you X moles of X, then this X moles of X gives you Y moles of Y, then this Y moles of Y gives you B moles of B. Its equilibrium constant is your K1, its equilibrium constant is your K2, its equilibrium constant is your K3, then your this K equilibrium is K1 into K2 into K3. Because once we do the multiplication of all these three, we'll get the same expression what we are having for the equilibrium constant of the original reaction. So whatever the number of steps we divide the reaction, each involving their individual equilibrium constant, overall equilibrium constant is always the product of these three or n number of steps.